Introduction to the topic. Hello, my name is Julian. Today I'm going to discuss a fascinating topic in modern physics related to the photoelectric effect. The photoelectric effect was first observed by Hertz and was famously explained by Albert Einstein. Einstein's explain was revolutionary. It showed that light behaves not only as a wave but also as particles or photons that can eject electrons for certain materials. This discovery laid the foundation for quantum mechanics and even won Einstein a Nobel Prize. The article I read titled Supreme Theory of Every Time a New Quantum Concept on the photoelectric effects takes a different approach from Einstein. It suggests that Einstein's model is incomplete because it jars the photoelectric effects as a simpler linear interaction. Instead, this article proposes a cyclical model that aims to explain the photoelectric effect more accurately, by introducing net concepts like open hypothesis and property of magnetic materials in the Fermi-Dirac distributions, which is aesthetical way to describe particles like electrons. This net model is a part of a larger theory called the super theory of everything, which sets to create more uniform understanding of the universe. Continue development of the topics. The article begins by critiquing Einstein's approach to the particles effect to the photoelectric effects, stating that the model needs to get beyond simple linear behavior. The author argues that encyclical appropriate uh, approach is more appropriate because it can capture the respective and opticality nature of certain quantum photomania. In Einstein's model, the photoelectric effect is straightforward when Lind is a material. It releases electrons, but the article suggests that some simplicity ignores many factors that affect electron behavior in complex ways. Wise. So, to support this cyclical model, the article introduces the Fermi-Dirac distribution. This is a statistical tool that describes the probability and finding electrons and different energy levels within a material. By applying Fermi-Dirac statistics, the author suggests that the behavior of electrons during the photoelectric effects is more accurately predicted, predicted especially and temperature and energy levels vary. Additionality and article highlights something uh, called open hysteresis. Hysteresis is general and property of magnetic materials, where in magnetic response lacks varying changes in the magnetic field. By incorporating this concept in the photoelectric effects, the author argues that it's possible to describe how different material affects the relates on electrons more precisely. This includes introducing an threshold frequency unique to each material. Below this threshold, this material won't relax electrons, re- regardless of line intensity. This adds complexity to the photoelectric effects and points to potential applications for material with unique tertiary properties. properties. Finally, the article discusses mathematical models that don't really an approximations on simulations. The author believes this model could lead to more accurate predictions, especially, especially useful in faith requiring precision with electron behavior such and in an electronics of or materials essential. Uh, Personal opinion. Uh, as a system engineering student, studying more modern physics and found this article very challenging, but also a opening. My background is mostly in computing and system, so concepts like the Fermi-Dirac distribution and magnetic hysteresis are not very familiar to me. However, I can see why they may be essential for understanding quantum mechanics and deeper level. One of the most interesting aspects from my perspective is how the article applies advanced mathematics with how simulation. And my friend, we often rely heavily on simulations to predict behavior, so the idea, idea, idea of using essential mathematics models that come above this is a key interesting in my meeting of potential application in system optimization or on developing more efficient algorithms in computing. I also see value in their own in understanding the topic, even if the same on the relation to system engineering and at first quantum mechanics has become increasingly relevant, especially with the rise of quantum computing, where understanding electron behavior is key. In fact, interdisciplinary knowledge like this can extension of understanding of complex problems in areas like artificial intelligence and data processing, where precision in prediction is valuable. Overall, it seems that while the article's theory is complex, the potential application in fields related to computing and technology make in work exploring further. Perhaps with more practical examples and experiments. This new model of the photoelectric effect could become more accessible, even for those of us in engineering fields outside of course physics. Thank you.